Hello everyone, and welcome to the second video of our fraction series here at Linear Abacus. In this video, we're going to learn how to count beyond 1 using unit fractions and groups. Now the aim of this video is to help you understand how numbers that are greater than 1 can have alternative names, which we write as improper fractions and mixed numbers. So here you can see that I've drawn the first full bag of marbles. And this is the same bag that I used in the previous video. So in the last video, we learned how to identify the unit fraction and count the unit fractions to give each of the marbles in this bag a fraction name. Now what we saw for that full bag of 12 marbles was that the unit fraction that we used was called twelfths. And when we counted all the twelfths, we found that we needed 12 of them to make the full bag. So what if I had another bag like I've drawn on this side? I'm going to show you how you can continue counting the unit fractions in this second bag. And as you can see, this second bag is identical to the first bag, which means that each of these marbles are also twelfths. And today we're going to count them to name the marbles in each bag as improper fractions and mixed numbers. I can model the two bags on the Linear Abacus, and to start I need to slide 24 beads across to the left-hand side. Now I'll split the beads into two parts to represent the two full bags, and I know that 12 beads are needed for each full bag, and again you can use colour in the string to determine this. If I was counting the individual things inside of the bags, I can use improper fractions to talk about more than one whole bag. And as we saw in the previous video, we can match each of the marbles to one bead on the abacus. And so here you can see we've got the counting sequence for twelfths. And we can do the same thing for the second bag. Now we can continue with the counting sequence to name the marbles in the second bag. So when I'm counting by twelfths, it makes complete sense for me to name the first marble of the second bag 13 twelfths, which I can express symbolically using fraction notation. The second marble in the bag would be called 14 twelfths. The third marble in the bag would be called 15 twelfths, and so forth. Colour in the beads is really helpful. You can see that this is called 15 twelfths because it is the 15th bead on the abacus string. Now you can continue with this sequence until you reach the last marble in the bag. Now just by looking at the beads on the abacus string, you'll see that the last marble would be called 24 twelfths, which is also equivalent to 2 full bags. Here is the full sequence when counting by twelfths. Do you see the counting numbers in this sequence? Take a moment to pause the video and reflect on this question. I hope you had some time to reflect on the question. So in this sequence, you can see that the counting numbers can be seen in the numerators of each successive fraction. And that makes sense because we're counting all the twelfths in both bags. Notice that the denominator doesn't change. This is because it talks about the size of the group that these parts are coming from. So what we found out so far is that when we're counting individual things, that is the twelfths in the bag of 12 things, then I can use improper fractions to count. But what if I wanted to focus on counting by groups of things? Well, now I would use mixed numbers. And a mixed number shows the number of groups and the fractions of the next group. So if I start with 1, which is a full bag of 12 marbles, I know that I'm still counting twelfths. But I'm going to label this bead 1 because now I'm focusing on counting groups of things. I still need to remember that I'm working with twelfths because this is how I'll be describing the second bag as I count each individual marble. The next bead, which represents the first marble in bag 2, would be named 1 out of the group of 12. And if I look at the collection that I have so far, I have 1 and 1/12 of a bag. I can continue this and call the next one 2 out of 12. So in total I would have 1 and 2/12 of a bag. The next marble would be 3 out of 12, and in total I would have 1 and 3/12 of a bag. And I would continue this process until I've counted every single marble in the second bag. Now, when I reach the last marble in the bag, I could express this in two different ways. I could think of this as 1 and 12/12 of a bag, which I should recognize as being 2 full bags. So the next thing to do is to label the linear abacus using both improper fractions and mixed numbers to show how these symbols in the sequence are actually naming the same quantity of things. And let's look at an example. Say we were looking at 16/12. We can see that this is also named 1 and 4/12, which can be connected to the statement below. I would read this statement as 16/12 is equivalent to 1 and 4/12. Now on the linear abacus, it's very clear how these two numbers are equivalent because they're pointing to the same bead. Now we're going to see how we can use the abacus to now construct a number line. We'll begin by drawing a length which is equivalent to the line of 24 beads, and we'll locate 2, we'll locate the 0, and we know that the halfway point here will be 1 full bag. Now to find 12ths, I can do this in a few ways. I'll look at how to divide each section, which are the wholes, into 12 equal parts. So what I'll do is I'll cut each half into 4 parts to make quarters. And notice here that I'm using the beads to make the 4 equal parts. Here I'm paying attention to 3 beads in a row. Now I'm going to partition each quarter into 3 parts to make 12ths. Notice that when I'm looking at the 16th bead on the number line, I'm looking at the end of the bead. This is what corresponds with the mark on the number line. And this particular point on the number line can be called 1 and 4 out of 12 or 16/12. What this shows is that it's the same point on the line, which means they are equivalent. In the next video, we will see how to convert between improper fractions and mixed numbers and vice versa using what we call descriptive calculations.